Assalamualaikum and salam sejahtera. Welcome back to our subject MEC111 Static. Today we're going to chapter 6 on analysis of structure. Today we're going to discuss more on 6.1.2 method of section. So method of section is used to find the force in only a few members of truss. We must treat S2D rigid body in equilibrium and cut through structural members to evaluate the force. The maximum numbers of unknown is 3. So example, we have this figure over here, which we want to find the force member in member B, D, BE and CE. So we make a cut over here to let the body to split into two. All unknown force must be directed upward, same as we do the analysis in a method of join. Here is one example. Find force in member BC, CG and FG. So first we need to identify which member that we need to analysis. So in this figure, the section that we want to inspect is member BC, CG and GF. So by the section that we made, so we draw the free body diagram for the section, which we have over here and the other half over here. The step for analysis in method of section, first thing is to draw the overall free body diagram as in figure B to find the reaction force at support by using equation of equilibrium rigid body. So we have a figure A where it has the problem, then we draw the free body diagram as in figure B. Mark all members on the truss that need to be solved as in figure A. So we mark here. Then pick the section and draw free body diagram of the selected section as in figure C. Make sure you have a maximum of 3 unknown. Here is we can see we have members FGE, member FGC and FBC, which we call as unknown. The fifth step is to apply equilibrium of rigid body equation to solve the unknown force, which is the summation of force in x and y direction equal to 0 and the summation of moment is equal to 0. Now let's do one example to practice the step that we have learned. Determine the force in members HI, HB and BC and determine whether the members are in tension or compression. So in this question, it clearly said that the members that we need to analyze, which is HI, HB and BC, which is located here. So we draw a line here. First step, we draw the overall free body diagram to find the reaction force at the support. Same as the method of join, you need to identify the types of support that we have to find the reaction at the support. At pin support, we're going to have two reactions, which is AY and AX, while at roller support, we're going to have one force acting, which is EY. By using the moment, summation of moment at point A, reason why we use moment A because it's to eliminate the unknown at A. So which leaves us with one unknown only, which is E. So by doing the summation of moment, we're going to solve it and get E is equal to 45 kilonewton. Using summation of force X is equal to 0, since there is only one force acting in X, which is AX, so AX will equal to 0. To find AY, by using summation of force in Y direction, we're going to get AY is equal to 65 kilonewton. Next is to mark all members that we need to solve, which is HI, HB, and BC, which is over here. Then we draw the free body diagram of the selected section, which we have here is one section and here is one section. We choose only one section to solve the unknown force. We can either choose this section or this section. The third step is to apply the equilibrium of rigid body equation to solve the unknown force. Here, by using summation of moment at point B, we select point B because B has two unknown that we can eliminate, so it left us with only one unknown, which is FIH. So by solving the equation of moment B is equal to 0, we're going to get FIH is equal to 35 kilonewton, which is negative, which shows that the members are in compression. Then to find FBH, since only FBH is moving in Y direction, here we need to resolve the force into X and Y component. In Y component, FBH sine 45 degree plus with 65 kilonewton minus with 30 kilonewton minus with 20 kilonewton equal to 0, and we're going to get FBH equal to negative 21.2 kilonewton. Negative sign shows that the force are in compression. Next, we try to find force in FBC. So by using summation of force in X direction, since FBC only moving in X direction, so we're going to get FIH plus FBC plus FBH cos 45, which is in X direction. So we're going to get FBC is equal to 50 kilonewton. Since it's in positive, it shows that the members are in tension. Here is another example. Determine the force in members BC, PE, and EF, and the truss, and state if these members are in tension or compression. Set P1 equal to 6 kilonewton, P2 9 kilonewton, and P3 12 kilonewton. The first step is to draw the overall free body diagram in order to find the reaction force at the support. We identify the type of support that we have, which is pin and roller. So at A, we're going to have two reactions, which is AX and AY. Then at D, we're going to have one force acting on Y direction. So we want to find the unknown, which is ND, AY, and AX. By using the summation of moment at point A, this is because A has the most unknown. So we're going to get ND is equal to 12 kilonewton. Since we have two forces acting in X direction, which is AX and 12 kilonewton. By using summation of force in X direction, we're going to get AX is equal to negative 12 kilonewton, which shows that the force are acting in the left direction. To find AY, we can use summation of force in Y direction, which we have AY minus 6 kilonewton minus 9 kilonewton plus with ND, and we're going to get AY is equal to 3 kilonewton upward. Next step is to mark all the members that we need to solve, which is EB, EF, and BC. So draw the free body diagram for the selected section, which we have over here. So the assumption that we need to have is that all unknown forces are acting outward, which is here, here, and here. Next step is to apply equilibrium of rigid body equation to solve the unknown force. Here, by using summation of moment at point E, since E has two unknown, which is FEF and FBE. By summation of moment at point E, we're going to get FBC is equal to negative 12 kilonewton, which shows that the FBC is 12 kilonewton in tension. By using summation of force in Y direction, we're going to get FBE is equal to 4.24 kilonewton, which are in tension. This force need to be resolved into X and Y component. By using summation of force X, we're going to find FEF. By substituting the value into the equation, we're going to get FEF is equal to negative 15 kilonewton, which shows that members are in compression. Here is a group work that you can try on your own. You can practice the step you have learned. The first step is to draw the free body diagram. First thing that you need to know is to identify the type of support. Draw the reaction at the support. And by using equation of equilibrium, you're going to find the reaction at the support. Next, mark the area that we want to analyze. In this case is FE, BC and BE, which is over here. Then cut the section and draw the free body diagram by using the equation of equilibrium particle. You're going to solve the problem. Here is another group work that you can try on your own. So with this group work, hopefully it will help you understand better and practice the step that you have learned in solving truss problem by using method of section. That's all for today's video. Hopefully you can understand. Hope to see you guys in the next video. Thank you for watching and bye bye.